So hello and good day. So ngayon, magdi-discuss tayo ulit ng another sample problem na mula sa lesson 2 or from the other group. So basahin natin sample problem. So a W8 by 35 steel column has a unsupported length of 8 meter using a 36 steel. Compute for the ultimate axial load capacity PU. A. If both ends are fixed, and B. If both ends are pinned. So the given are A is equals to 6,645.15 millimeters squared. The IX is equals to 52.45 by 10 raised to 6 millimeter raised to 4. The IY is equals to 17.69 millimeter raised to 4. RX is equals to 88.9 millimeter and the RY is equals to 51.56. So since ang pinapahanap sa atin ay the ultimate axial load or the PU and or yung LRFD, and since yung column natin ay symmetrical, ang radius of creation na ating gagamitin is the R minimum or the SR max. So to solve for the ultimate axial load, so first gagamitin natin or hahanapin muna natin yung slenderness ratio. So for our solution, so the design axial load is greater than or equal to the ultimate axial load. So for the for the end, if both ends are fixed, we have k is equals to 5. So yung ating slenderness ratio, we have the formula of KLY is equals to RY. So the direct substitution lang. So 0.5 multiplied by the 8 meters or 8,000 millimeter divided by the RY, which is 51.56. So, makakakuha tayo na slenderness ratio is equals to 77.58. So, next, ang hahanapin naman natin ay yung CC to determine kung anong klase siya na column. So, meron tayong formula for CC is 4.71 multiply the square root of E over F sub FB. So, direct substitution lang, 4.71. Yung modulus of elasticity natin is 200 GPa. So, 200 E raised to multiply by, times 10 raised to 3. So, yung FB natin is 248. So, makakuha tayo ng value na CC na 133.755. So, ngayon, since kung mapapansin nyo, yung slenderness ratio natin ay less than siya sa CC. So, ang ating column ay papasok siya sa classification ng um, intermediate column. So, since as intermediate column siya, ang gagamitin natin na formula for FCR is 0.658 multiplied by Fy over Fe multiplied by Fi. And to solve Fe, meron tayong formula na pi squared E over KL RY raised to 2. So, direct substitution lang, pi over 2, pi raised to 2, multiply the elasticity modulus, so 200 times 10 raised to 3, and over K natin yung stiffness na 0.5, multiply the length na 8,000 millimeter, and RY na 51.56 raised to 2. So, makakakuha tayo na value ng FE na 327.971 MPa. So, para ma-solve naman natin yung FCR, so direct substitution lang siya. FCR is equals to 0.658, yung FY, 248, over 327.971 multiply by 248 So makakuha tayo na value ng FCR is equals to 180.718 MPa. So para ma-solve natin yung yung PU or yung ultimate axial load, it is less than or equal to the design load. Okay, so next is meron tayong formula na the ultimate axial load is less than or equal to the design load equals to 0.9 FCR area gross. So direct substitution lang din. So ultimate axial load is equals to 0.9. FCR natin is 180.718 multiply by the area na 6,645.15. So may makukuha tayo na ultimate axial load na 1,080.806 kilonewton. So ito yung ginamit natin and ito yung way na pag-solve para sa both ends are fixed. So sa pag-solve naman natin for the letter B or the if both ends are pinned, ang pinagkaiba lang niya is yung K, yung value ng K natin is magiging equals to 1.0 or yung value ng slenderness ratio is magiging 2 times lang siya. So dito, using the same formula na no slenderness ratio is equals to KLY over RV. So yung SRY natin is equals to 1 multiplied by 8,000 over 51.56. So may makukuha tayo na value na 155.159. So next is to solve for the CC. So same formula lang din. Yan. So yung CC natin, nakuha na natin siya kanina is 133.755. So kung mapapansin nyo dito na mas malaki na yung slenderness ratio compared to CC. So mako-consider siya as long column. So since long column siya, mag-iiba na dito yung value ng yung formula ng FCR, pero yung pagkuha natin sa FE is mananatili siyang the same. So yung magiging formula na for FCR is equals to 0.877 FE. So ngayon, solve ulit natin yung FE. So ito, mag-iiba kasi yung value ng FE natin since yung K natin is equals to 1 na. So FE is equals to pi squared E, which is the modulus 200 times 10 raised to 3. Then, divide siya sa K na 1 over 8,000 over RY na 51.56 squared. So, may makukuha tayo na value ng FE na 8,000 divided by 51.56 squared. So, may makukuha tayong value ng FE na 81.993. So, to solve naman yung FCR, so yung FCR natin is equals daw siya sa 0.877 ng FE, which is 81.993. So, yung FCR natin ay 71.908 MPa. So next, since meron na tayong FCR, so solve na natin yung ultimate axial load. So yung ultimate axial load natin is less than or equal to the design load. So, same lang siya na 0.9 FCR, area gross. So, yung ultimate actual load is equals to 0.9 direct substitution, FCR, 71.908 multiplied by 6645.15. So, ang ultimate actual load natin ay 430.056 kilonewton. So, yun lang po. And thank you sa pakikinig at panonood.